We'll talk about dynamic binding in this video. Suppose we have an inheritance chain where the parent class starts on the left, Cn being the superclass of Cn-1, Cn-1 being the parent class of Cn-2, so on and so forth. And the very last object is C1. So C1 is also a subclass of C2, which is a subclass of C3, so on and so forth. This means Cn is the most general class, or in Java, java.len.object. Let's say if there's a reference object O pointing to C2, this dynamic instance has a whole bunch of methods. If we were to invoke a method P on O, namely O.P, the JVM searches the implementation for the method P from this point on C2. If not found, it goes into C3. If not found, it goes into C4 until the implementation of P is found in the closest superclass. Once the implementation is found, the search stops and the first found implementation is invoked. This whole process, as described, happens at runtime, hence the name dynamic. This is also what's referred to as late binding, as opposed to early binding, which is compilation time. Late binding, dynamic binding, or runtime binding is the process where the method to be called is determined at runtime rather than at compile time. This is a fundamental concept in object-oriented programming, enabling polymorphism. Let's look at early and late binding again in the next slide. We talked about compilation time and also runtime. During compilation or early binding, matching happens. Matching a method signature according to its parameter type, number of parameters, and the order of parameters is the key. These are early binding processes. Later on at runtime, we have what's called dynamic binding or late binding. This is when the Java virtual machine dynamically binds the implementation of the method at runtime. One example of an early binding is method overloading, which occurs when multiple methods in the same class have the same name, but different parameters like their types, number, or both. The method to be executed is determined at compile time based on the method signature. On the other hand, method overriding occurs when a subclass provides a specific implementation of the method that is already defined in its superclass. The method to be executed is determined at runtime based on the object's actual type. This process is called method overriding, late binding. It turns out polymorphism allows the method to be used generically for a wide range of object arguments, as we see here in the prior example, where the static M method takes in an object. When this M is invoked, you can actually pass in any of the object's subclass, like person, student, or graduate student. This is known as generic programming, a concept that is very similar to Java generics, which was introduced in Java 5 that allows you to write classes, interfaces, and methods with type parameters inside this angle bracket, a letter T's inside. But we're not talking about that generics. We're talking about this type of generics involving the parameter type being either a superclass or supertype or a subclass or subtype. Through polymorphism and dynamic binding, we can pass those objects of various different types and trust that Java virtual machine would be able to invoke the correct instance methods associated with the object that invokes it. Namely, if we pass in a student object, we expect polymorphism to be able to pick the right toString associated with the student toString and not the object toString, so on and so forth.